Another helpful factoring pattern is factoring by grouping. It can help us to factor things of a higher degree than just a regular quadratic. It can also be helpful for a trinomial that has an a value in the front that's a little bit complicated, or when there's more than one variable. So the idea of factoring by grouping is given away by its name. We're going to group the first two terms and we're going to group the last two terms. We're going to take out a common factor and then continue to factor from there. So when we look at this question, we're going to have a group here and we're going to have a group here. So for the first group, common factor, 2 and 5, well those are prime numbers, so there's no number to take out, but we have an x cubed and an x squared. What's the biggest x to the biggest power that we can possibly factor out here? X squared. And that leaves us with 2x plus 5. In the second part, what can go into 6x and also into 15? 3. And we have negatives in both places, so let's take out a negative. So negative 3, and we're left with 2x. And if we take 3 out of 15, negative 3 out of 15, we'd have plus 5. So something really special has happened here. We have two terms that look the exact same. So now we can do another common factoring. It's a little bit hard to see like this, but maybe if I write it a little bit differently. So we have x squared times something. Let's just get rid of that something, make it a little bit simpler for a minute. Let's let a equal 2x plus 5. Now what I'm doing over here on the right side, we don't usually do all this work, but it's just to try to explain why we're doing what we're doing, how factoring by grouping works. So 2x plus 5, it's big, it's bulky, it makes it a little bit difficult to work with, so let's just replace it by a. Then we have minus 3, and again 2x plus 5, so let's call that a still. When we factor this, it's really easy to see now that we have a common factor of a. So let's take out the common factor of a, and we're left with x squared minus 3. Okay, so notice we had a common factor in the first term, a common factor in the second term. So we took out the common factor. Even though it looks a little bit more complicated here on the left side, it's still the same thing. We have a common factor in the first term, and the second term, this big second term, has the same common factor. So let's take out that common factor. So when we take the common factor out of the first term, we're left with x squared. We take the common factor out of the second term, we're left with minus 3. And that worked out really nicely. Now, if you're asked to factor fully, this x squared minus 3, we could look at it and try to figure out if we can factor it more. It kind of looks like a difference of squares. There's one reason why it doesn't work. 3 is not a perfect square. So we're done. Sometimes we can be given a simple trinomial, and we might be able to use factoring by grouping. So for example, 6x squared plus 17x plus 7. You can use a few different strategies. You can have a little mnemonic device to help you remember, like the man rule. It gets a little more complicated when the a value is not 1. You could just do it by guessing and checking, and that's what I do most of the time. I would just guess and check. But you could also try factoring by grouping. So if we can get it so the beginning part and the last part have a common factor, then we can take out a common factor. So let's think about this here. Is there a way to split up the middle term so that we'll get a common factor. So we have 17x here. If we had 7x here, we could take out the 7. But what will that leave us with here? That'll leave us with 10x. We won't have a common factor. We're going to plus something x plus something x. Okay. Maybe something that is a factor of 6 if we try 12. And then we're left with 5. That's not very promising. Maybe 14, and what's left over 3. Okay, here. So now we see that 6 is twice as much as 3, and 14 is twice as much as 7. So we might be able to get a common factor if we take out 2. So on this end, if we take out 2, we're left with 7x. We don't want to take out 2, we want to take out 7. If we take out 7, we're left with 2x plus 1. And here if we take out 3 and x, because there's a common factor of x here, we're left with 2x plus 1. And now our common factor here, we can take that out. 2x plus 1. And what's left over? 3x plus 7. And we factored it. So what do you think is easier here for this trinomial? Factoring by grouping or just guess and check? So if I did just guess and check, I would probably just set up some brackets, put in what I know. I know I need an x. Everything's positive everywhere, so it's probably going to be positives. 7 only has 2 possible choices. I could have 1 and 7 here. I could have 7 and 1 the other way. And then 6, you can look at 6. It could be 1 and 6, or it could be 2 and 3. Not a whole lot of choices to try, so we could try 2 and 3. That gives us 3x plus 14x, which gives us the middle term, 17x. So we're done. Had you made a mistake, and if you did, (2x and 3), and you tried this first, wait, that's what I did last time. I'm trying to show you what to do when you make a mistake, and I didn't make a mistake. Okay, so guess and check. If you tried this, okay, so that would be 2. 3 times 7 is 21. Add it together and get 23. So you can see that this would fail. And in the guess and check process, if you had tried this, then you would flip it and try it the other way, and then you would get the correct answer like we had previously. Okay? So that's factoring by grouping. The main idea is you group the first 2 terms, you group the last 2 terms, take out a common factor from the first 2, take out a common factor from the last 2. And then now you have 2 terms, the first term and the last term. You look for a common factor in each of these and take it out. So it's almost like you do 3 common factoring to get this factored. It doesn't work in every single situation, but it's helpful when it does work.